So this is Min. I will have a presentation on assessing stroke rehabilitation exercise, which is jointly done by Dan, Asim, Alex, and Sergi. And in this presentation, I will briefly describe how computer system can support assessing rehabilitations. And I will describe the design of the stroke rehabilitation exercise, rehabilitation study, and our proposed method about automatically assessing the stroke rehabilitation exercise, and our validation results, conclusion, and future work. So post-stroke survivor require repetitive physical therapeutic session. However, this is expensive and time-consuming because it requires presence of the therapist for assessment and generating useful feedback. And as the therapy has a limited availability, they often prescribe in-home rehabilitation where a patient has to perform particular prescribed exercise themselves. And during in-home rehabilitation, patients often become unmotivated or confused whether they correctly following the prescribed exercise. And also therapists have a problem with tracking the patient's progress over the time. So researchers attempt to improve the rehabilitation practices with the computer technology. So first, they try to log and analyze sensor data to track the exercise metrics such as joint angle and number of repetition. However, according to the user study, the therapists consider that analyzing sensor data is still not intuitive to understand individuals' patients' performance. And another approach is to classify the occurrence of the incorrect motion with the sensor data and machine learning. However, the problem is this one provides intuitive detection. The problem is that this simple binary detection cannot provide the diverse level of the patient's performance. So there is a need of quantifying exercise performance, and researchers start exploring the usefulness of kinematic variable for quantitative assessment. And for example, like they correlate the kinematic variable with the clinical score, but still the limited work has explored how we could actually quantify and it works compared to the human. So this research proposed a development of the intelligent therapist, which can describe the exercise and observe the patient's exercise performance with the Kinect sensor and summarize exercise performance with the machine learning and deliver some suggestion for improvement. So this is some running example, and I have demo, but I will skip for the sake of the time. And in this paper, I'll mainly address following three questions. The first one will be how we could actually automatically assess the exercise performance. And second one is like how well it could align compared to the therapist evaluation and whether such computed score has any clinical relevance. Now I will describe about our design of stroke rehab study. So we mainly utilize a 3 task-oriented upper limb exercise. Bring a cup to the mouth where the patient has to grab a cup and reaching to the mouth area as if they're drinking water. And exercise 2 is the patient has to reach forward to switch a light on. As exercise 3, they need to extend the elbow to move the cane forward. And for the evaluation of the stroke rehabilitation exercise, we utilize 3 performance components: range of motion, smoothness, and compensations. And range of motion indicates how well individual achieve the task, and smoothness describes the degree of the trembling motions. And compensation is to detect whether there is unnecessary joint motion to compensate the patient's limited functional ability. For example, when patient here is doing bring a cup to the mouth, like compared to the unaffected side, patient start raising the shoulder instead of due to his limited ability on his wrist position. And given these performance components, we have also the therapist scoring guideline on a 3-point ordinal scale, which can be also mapped into binary label, the correct or incorrect. And those are the basically based on the clinically validated stroke rehab assessment tool of motor function test and Fugl-Meyer assessment. And now I will describe about our proposed automated assessment method. So to summarize our overall flow, so given an exercise trial, we will track the joint position and extract feature, and we'll train a binary classifier to detect the occurrence of the incorrect motion. And then leveraging the binary classifier, we will implement the threshold model to quantify the performance score. And now I'll first describe about the feature extraction parts. So we track like 16 joints, and we track multiple. We compute like multiple kinematic feature. Like joint angle indicates the angle between three selected joints, and relative trajectory indicates the Euclidean distance, and projected trajectory indicates absolute distance in particular axis. And we also have some speed-related measurement and some normalization to compensate the individual difference. And given this feature, we also have like these three performance components. So we ended up like the extract like the number of feature for each of them. The range of motion is composed of some like joint angle and distance measurements, and smoothness is mainly composed of the speed-related one and the on the elbow and wrist joints. And the compensation is also composed of the joint angle and distance to represent the occurrence of the compensate motions. And then basically we also, given this feature set, we compute the statistics over the frames to summarize the exercise the motion. The rationale is that here, for example, given the unaffected and affected side, we can see obviously the distinguish two sides based on checking the maximum points. So we compute maximum, minimum, and standard deviation, average, and range, given the feature that I described earlier. And now I will describe about the classifier and the implementation about the threshold model. So for binary classification, we implement the traditional linear regression, decision tree, SCVM, neural network, and LSTM on multiple limited parameter, and we did just grid search to pick like the best performing one. And given the binary classifier here, I describe about quantification. So basically, quantification is our intuition is an intermediate problem between classification and regression, where we need to predict the categorical performance score, like 0 no motion, like 1 limited, 2 full normal motion. So this is like the original regression problem, and one popular approach is a threshold model with the binary classification, where the well-tuned binary classification can provide the ranking score, which can be leverage with the sets of threshold value to estimate the categorical response. So we implement this threshold model with the binary classification for quantification. Now I will describe about our validation study. So we recruited 15 post-stroke survivor and 11 healthy subjects. And totally we collected the 485 trial of the exercise for each one. And then for generation of the ground truth, we recruited the two therapists, primary and secondary. And the primary is referring to the one who supported the recruitment of the patients and then evaluate their functional ability. And secondary therapists has like no prior interaction with the patients. And then they ended up perform like two evaluation. One individually watched their recorded video and assign score based on the scoring guideline, and then they had like 1 hour discussion to share their knowledge about the assessment to reduce some of the disagreement, and did another evaluation phase. And basically the rehabilitation process mainly managed by the therapist from beginning to the end. So we decided to pick like the primary therapy as like our ground truth score. And this table summarizes our results about binary classification. So we just used the leave one subject out cross validation, where we trained the model without leaving the testing subjects, and apply the testing on these left held out the subjects. And here we compare the F1 score on multiple models, and overall we found that the neural network and decision tree works well. And we expect the LSTM might works well, but we found it's a bit difficult to derive the well-tuned model. And given this outperforming the neural and decision model, we implement the threshold model and compare with the traditional multi-class and regression one. And overall, the threshold model seems to be works outperform than the multi-class and regression. And sometimes multi-class regression works slightly better. But overall, we could observe that the threshold model is like at least like the intermediate solution of multi-class and regression. And compared to the when we apply the statistical significance testing with the paired t-test, we found that threshold model can generate equally good solution with the multi-class regression. And the same trends can be observed on the MSA value. And for answering the how close